This particular question is, if fx equals 4, x raised to the power 12 minus 5, x cube plus 10 equals 0, has 12 roots, alpha 1, alpha 2, alpha 3 till alpha 12, and gx equals x square plus 13x plus 169, find the value of g of alpha 1 into g of alpha 2 into g of till g of alpha 12. So this particular question involves functions. Okay, this involves complex numbers as well. So this could be a good concept for JEE Advanced. Okay, so for this particular question, theory of equations is also involved. So for this particular question, what we can do is, first we'll write fx. So f of x is equal to 4x raised to the power 12 minus 5x cube plus 10, right, is equal to 0. Now this has 12 roots, alpha 1, alpha 2, alpha 3. So using factor theorem, we can say if alpha 1 is a root, x minus alpha 1 is a factor. So we can write x minus alpha 1 into x minus alpha 2 into x minus alpha 3 till we have x minus alpha of 12, right? Now see, the coefficient of x raised to the power 12 on right hand side is 1. Here the coefficient, left hand side, the coefficient is 4. So we have to multiply with 4 over here, right? So we can see that this is an identity from here to here. Okay, this is an identity. So we can say that this is equation 1, right? Now if you check gx, so gx is what? X square plus 13x plus 169. Okay, this is gx. Let's say we write gx equals 0. We'll have x equals minus 13 plus minus square root of 13 square minus 4 times 13 square, 169 is 13 square upon 2, right? So if you take minus 13 common, or let's say if you take 13 common here, so you'll get minus 1 plus minus root 3 iota upon 2, which is omega and omega square, right? So we can see that 13 omega and 13 omega square are the roots of gx, right? Where omega is, what is omega and omega square? They are complex cube roots. What are they? Complex cube roots of 1, right? Of 1 unity. So gx equals 0 involves this one, right? So we have g of alpha 1. Now we can write gx. If these are the roots, we can write gx as x square plus 13x plus 169, right? Now this is equal to x minus 13 omega into x minus 13 omega square. We can see that these are the roots, right? Now we have to find g of alpha 1, right, into g of alpha 2 into, so we can write this is product of g of alpha r equals 1 to 12, right? This is the product which we are finding, right? So this is what now g of alpha r. So in this g of x, we have to put alpha r over here. So whatever is this expression, in this expression we have to put alpha. So what we'll do is we'll write r equals 1 to 12. Now gx. So instead of x, we have to substitute alpha r. So this is alpha r minus 13 omega into alpha r minus 13 omega square. So we can split about the product. We can write r equals 1 to 12, and we can write here alpha r minus 13 omega square, right? Now this is product of, this is basically alpha r minus 13 omega, right? So this alpha r we have to substitute over here, right, in the first one. Now using equation 1, we can say that this product is equal to, okay, this product is equal to 4 times. Now instead of x, we need to put 13 omega, right? So this will become 4 into 13 omega raised to the power 12 minus 5 into 13 omega raised to the power 3 plus 10 upon 4 So this would be one of the values. Now the second value we have to substitute 13 omega square. So this will become 13 omega square raised to the power 12 minus 5 into 13 omega square raised to the power 3 plus 10 upon 4. Okay. Now see, if you put omega raised to the power 3 is 1, right? So this will become 4 into, now this will become 13, right? 13 raised to the power 12 minus omega cube is 1 again. So this will become 5 into 13 raised to the power 3 and then plus 10 upon 4. Now the second factor will also become same. So we have this whole square. So this is the answer of this question. Okay. Thank you. Thanks a lot. So in this particular question, what all has been involved, which chapters has been involved? First is theory of equations, factor theorem here. Then we have complex numbers. And after complex numbers, we have functions as well. Okay, composite function. Okay. Thank you. Thanks a lot.